Hello children, welcome to the science video session. In this video session, you are going to learn the lesson Electricity from Physics of Standard 8. Come, let's get started with the lesson.
Unit 5 Electricity. Introduction. All things we use in our life are made up of elements. Each element is made up of atoms, which is the smallest unit. This we already know very well. In earlier lesson, we have learned that John Dalton, the scientist, considered that atoms cannot be divided further. But it was found out later through Rutherford's gold foil experiments that atoms are made up of particles like proton, electron, and neutron, isn't it? So, the movement of electrons in a material constitutes electric current and generates an energy called electric energy or electricity. The movement of electrons from one atom to another atom is shown in the picture. We use this energy in our life for various needs. Electric bulbs, fans, electric iron box, washing machine and refrigerators are some of the appliances which work with the help of electricity. In this lesson, we will study about electric charges and how they are transferred. This lesson will also cover electric circuits and the effects of electric current. Come, let's enter into the lesson. First, we are going to know about atom. As we already know, that atom consists of proton, electron and neutron, which are called subatomic particles. Proton and neutron are found inside the nucleus, which is at the center of an atom. Electrons revolve around the nucleus in different parts called orbits. In an atom, the number of protons and the number of electrons will be equal. There is a force of attraction between the protons in the nucleus and the electrons in the orbits. Electrons in the inner orbit are strongly attracted by the protons and they cannot be removed from the atom easily. But the electrons in the outermost orbits are loosely bound and they can be easily removed from the atom. And this will be the reason to get the electricity. Next, charges. Charge or electric charge is the basic property of matter that causes objects to attract or repel each other. It is carried by the subatomic particles like protons and electrons. Charges can neither be created nor be destroyed. There are two types of charges. One is positive charge and another one is negative charge. Protons carry positive charge and electrons carry negative charge. There is a force of attraction or repulsion between the charges. See, here like charges repel each other and unlike charges attract each other. The attraction and repulsion of charges are shown in the picture. Electric charge is measured in coulomb in capital C. Small amount of charge that can exist freely is called elementary charge. Its value is 1.602 into 10 to the power of minus 19 C. That is coulomb. This is the amount of charge possessed by each proton and electron. But protons have positive elementary charge and electrons have negative elementary charge. Since protons and electrons are equal in number, an atom is electrically neutral. Transfer of charges. As we saw earlier, electrons in the outermost orbit of an atom can be easily removed. They can be transferred from one substance to another. The substance which gains electrons become negatively charged because the number of electrons is high in this case. And the substance which loses electrons become positively charged. Transfer of charges takes place in the following three types: transfer by friction, transfer by conduction, and transfer by induction. Next, transfer by friction. This we can understand by a simple activity. Take a comb and place it near some pieces of paper. Are they attracted by the comb? No. Now comb your dry hair and place it near them. What do you see? You can see that the paper pieces are attracted by the comb now. How is it possible? See, comb rubbed with hair gains electrons from the hair and becomes negatively charged. These electrons are accumulated on the surface of the comb. When a piece of paper is teared into bits, positive and negative charges are present at the edge of the bits. Negative charges in the comb attract positive charges in the bits. So, the paper bits are moving towards the comb. While combing hair, charges are transferred from the hair to comb due to friction. If the hair is wet, the friction between the hair and the comb reduces, which will reduce the number of electrons transferring from hair to comb. Hence, rubbing certain materials with one another can cause the buildup of electric charges on the surfaces. This you can understand by the given pictures very clearly. From this, it is clear the charges are transferred by friction. Similar effect can be seen when we rub few materials with one another. When a glass rod is rubbed with a silk cloth, the free electrons in the glass rod are transferred to silk cloth. It is because the free electrons in the glass rod are less tightly bound as compared to that in silk cloth. Since the glass rod loses electrons, it has a deficiency of electrons and hence acquire positive charge. But the silk cloth has excess of electrons, so it becomes negatively charged. This you can see by the given picture. When an ebonite rod means the rod made by vulcanized rubber, that means hard rubber, is rubbed with fur, the fur transfers electrons to the ebonite rod because the electrons in the outermost orbit of the atoms in fur are loosely bound as compared to the ebonite rod. The ebonite rod which has excess electrons becomes negatively charged and the fur which has deficiency of electrons is positively charged. The transfer of charge in ebonite rod is given in the picture. From this, we know that when two materials are rubbed together, some electrons may be transferred from one material to the other and leaving them both with a net electric charge. Do you know, if a negatively charged glass rod is brought near another glass rod, the rods will move apart as they repel each other. If a positively charged glass rod is brought close to a negatively charged ebonite rod, the rods will move toward each other as they attract. The force of attraction or repulsion is greater when the charged objects are closer. Transfer by conduction. This we can understand by a simple activity. Take a sheet of paper, turn it into a hollow cylinder. Tie one end of the cylinder with a silk thread and hang it from a stand. Now take an ebonite rod and charge it by rubbing it with a woolen cloth. Bring this charged ebonite rod near the paper cylinder. The cylinder will be attracted by the rod. If you touch the paper cylinder by the charged rod, you will see the paper cylinder repelling the rod. Can you say the reason? Yes. When the ebonite rod is rubbed with woolen cloth, electrons from the woolen cloth are transferred to the ebonite rod. Now, ebonite rod will be negatively charged. When it is brought near the paper cylinder, negative charges in the rod are attracted by the positive charge in the cylinder. When the cylinder is touched by the rod, some negative charges are transferred to the paper. Hence, the negative charges in the rod are repelled by the negative charges in the cylinder. Thus, we can say that charges can be transferred to an object by bringing it in contact with a charged body. This method of transferring charges from one body to other body is called transfer by conduction. Do you know the materials which allow electric charges to pass through them easily are called conductors of electricity? For example, metals like aluminium, copper, brass, silver are good conductors of electricity. And materials which do not allow electric charges to pass through them easily are called insulators, like rubber, wood, and plastics. Transfer by induction. We saw that we can charge an uncharged object when we touch it by a charged object. But it is also possible to obtain charges in a body without any contact with other charged body. The process of charging an uncharged body by bringing a charged body near to it but without touching it is called induction. The uncharged body acquires an opposite charge at the near end and similar charge at the farther end. This we can understand by a simple activity. Bring a negatively charged plastic rod near a neutral rod. When the negatively charged plastic rod is brought close to the neutral rod, the free electrons move away due to repulsion and start piling up at the farther end. This you can understand by the given picture, the neutral body and the charged body. The neutral body and the charged body is given in the picture. Charged body is nothing but is the plastic rod. It's negatively charged. Okay, so next the charge is getting concentrated at the ends due to charged particles. Then the near end becomes positively charged due to deficit of electrons. Deficit of electrons means shortage of electrons. When the neutral rod is grounded, that means it's connected to the earth, the negative charges flow to the ground. So what will happen now? The positive charges at the near end remain held due to attractive forces, and n, the electrons inside the metals becomes 0 because all the electrons are fall down to the ground. Okay, next, when the rod is removed from the ground, the positive charges continue to be held at the near end. This makes the neutral rod a positively charged rod. Okay, the last picture shows you that the neutral rod is positively charged rod now. Similarly, a positively charged rod is brought near an uncharged rod. Negatively charged electrons are attracted towards it. As a result, there is the excess of electrons at nearer end and deficiency of electrons at the farther end. The nearer end of the uncharged rod becomes negatively charged and far end is positively charged. Flow of charges. Suppose you have two metallic spheres, one having more negative charge, that means excess of electrons, and the other having more positive charge, that means deficiency of electrons. When you connect them both with the help of a metallic wire, excess electrons from the negatively charged sphere will start flowing towards the positively charged sphere. This flows continues till the number of electrons in both the sphere is equal. Here, the positively charged sphere is said to be at higher potential. That means the red metallic ball. And the negatively charged sphere is said to be at lower potential, the green color metallic ball. Hence, electrons flow from lower potential to higher potential. This is known as electric current. That means the flow of electrons. So the difference between these potential is known as potential difference, commonly known as voltage. Okay, so the electric current is flows from lower potential to higher potential. See, before the discovery of electrons, it was considered that electric current is due to the flow of positive charges. Flow of positive charges is called conventional current. So conventional current flows from higher potential to lower potential. Electroscope. An electroscope is a scientific instrument used to detect the presence of electric charge on a body. In the year 1600, British physician William Gilbert invented the first electroscope. It is the first electrical instrument. There are two types of electroscope, pith ball electroscope and gold leaf electroscope. An electroscope is made out of conducting materials, generally metal. It works on the principle that like charges repel each other. In a simple electroscope, two metal sheets are hung in contact with each other. They are connected to a metal rod that extends upwards and ends in a knob at the end. Do you know the first electroscope developed in 1600 by William Gilbert was called Vesorium. The Vesorium was simply a metal needle allowed to pivot freely on a pedestal. That means on a base or a support. The metal would be attracted to charged bodies brought near. Movement of charges in electroscope. If we bring a charged object near the knob of the electroscope, electrons will either move out of it or into it. This will result in charges accumulating on the metal leaves inside the electroscope. If a negatively charged object or rod is brought near the top knob of the electroscope, it causes free electrons in the electroscope to move down into the leaves and leaving the top positive. Okay, this you can understand by the given picture. Since both the leaves have negative charge, they repel each other and move apart. And what will happen if we remove the charged object? Again, the metal leaves falls back. Now, we are going to bring a positive object near the knob of the electroscope. Now, the free electrons in the electroscope starts to move up towards the knob. This means that the bottom has a net positive charge. The leaves will spread apart again. Gold leaf electroscope. The gold leaf electroscope was developed in 1787 by a British scientist named Abraham Bennett. Gold and silver are used in electroscope because they are the best conductors of electric current. Now, the structure of electroscope. It is made up of a glass jar. A vertical rod is inserted into the jar through a cork. The top of the brass rod has a horizontal brass rod or knob or a brass disc. Two gold leaves are suspended from the brass rod inside the jar. Now, the working of electroscope. When the brass disc of the electroscope is touched by the charged object, electric charge gets transferred to the gold leaf through the rod. This results in gold leaves moving away from each other. This happens because both the leaves have similar charge. This we already seen in the movement of charges in electroscope, isn't it? Next, what is meant by charging? Transfer of charge from one object to another is called charging. In case of the gold leaves, charge is transferred through the brass rods. Next, electric discharge. The gold leaves resume their normal position after some time. This happens because they lose their charge. This process is called electrical discharge. The gold leaves would also be discharged when someone touched the brass rod with the bare hands. In that case, The charge is transferred to the earth through the human body. Lightning and thunder. Lightning is produced by discharge of electricity. Come, let's understand the discharge of electricity from a simple activity. Rub your foot on a carpet floor and touch a doorknob. What do you feel? Do you feel the shock in your hand? Definitely. Why does this happen? The reason? Getting a shock from a doorknob after rubbing your foot on a carpet floor results from discharge. Discharge occurs when electrons on the hand are quickly pulled to the positively charged doorknob. This movement of electrons, which is felt as a shock, causes the body to lose negative charge. Electric discharge takes place in a medium, mostly gases. Lightning is another example of discharge that takes place in clouds. Come, let's see how the lightning is happening. Formation of lightning. Lightning is produced by discharge of electricity from cloud to cloud or from cloud to ground. During thunderstorm, air is moving upward rapidly. This air, which moves rapidly, carries small ice crystals upward. At the same time, small water drops boom downward. When they collide, ice crystals become positively charged and move upward, and the water drops become negatively charged and move downward. So the upper part of the cloud is positively charged and the lower part of the cloud is negatively charged. Understand by the given picture? When they come into contact, electrons in the water drops are attracted by the positive charge in the ice crystals. Thus, electricity is generated and lightning is seen. Sometimes, the lower part of the cloud, which is negatively charged, comes into contact with the positive charges accumulated near the mountains, trees, and even people on the earth. This discharge produces a lot of heat and sparks that results in what we see as lightning. Huge quantities of electricity are discharged in lightning flashes, and temperature over 30,000 degrees Celsius or more can be reached. This extreme heating causes the air to expand explosively fast and then they contract. This expansion and contraction create a shock wave that turns into a booming sound wave known as thunder. Sometimes lightning may be seen before the thunder is heard. This is because the distance between the cloud and the surface is very long and the speed of light is more than the speed of sound. Do you know? During lightning and thunder, we should avoid standing in ground or open spaces. You should make yourself as small as possible by squatting. That means sit with bent knees. It is, however, safe to stay inside a car because the car acts as a shield and protects us from the electric field generated by the storm. Earthing. A safety measure devised to prevent people from getting shocked if the insulation inside electrical devices failed is called earthing. Electrical earthing can be defined as the process of transferring the discharge of electrical energy directly to the earth with the help of low resistance wire. We get electrical energy from different sources. Battery is one such source. We use it in wall clocks, cell phones, etc. For the working of refrigerators, air conditioners, washing machines, televisions, laptops, and water heaters, we use domestic power supply. Usually, an electric appliance such as a heater, an iron box, etc., are fitted with the three wires, namely live, neutral, and earth. Usually, the live wire is in red color, and the neutral wire is in blue color, and the earth wire is in green color. The earth wire is connected to the metallic body of the appliance. This is done to avoid accidental shock. Suppose due to some defect, the insulation of the live wire inside an electric iron is burnt, then the live wire may touch the metallic body of the iron. If the earth wire is properly connected to the metallic body, current will pass into the earth through the earth wire and it will protect us from the electric shock. The earth, being a good conductor of electricity, acts as a convenient path for the flow of electric current that leaks out from the insulation. Lightning arresters. Lightning arrestor is a device used to protect building from the effect of lightning. Lightning conductor consists of a metallic lightning rod in the form of spikes that remains in air at the top of the building. Major portion of the metal rod and copper cable are installed in the walls during its construction. The other end of the rod is placed deep into the soil. When lightning falls, it is attracted by the metallic rods at the top of the building. The rod provides easy route for the transfer of electric charge to the ground. In the absence of lightning arrestor, lightning will fall on the building and the building will be damaged. Electric circuits. We saw that when two oppositely charged spheres are connected by a metal wire, electrons flow from the sphere which is at lower potential to the sphere at higher potential. Similarly, if two terminals of a battery which are at different potential are connected by a metallic wire, electrons will flow from negative terminal to positive terminal. The path through which electrons flow from one terminal to another terminal of the source is called electric circuit. A simple circuit consists of four elements. They are a source of electricity, that means battery, a path or conductor through which electricity flows, that is wire, a switch to control the circuit, and an electric resistor, that is lamp, which is any device that requires electricity to operate. The given picture shows a simple circuit containing a battery, two wires, key, and electric bulb. The source can be battery or the electric outlet in your room. The electrical resistor refers to the device that consumes the energy. Control, that is key, is the mechanism that is used to start, stop, and regulate the electric current. When the key is on, electrons from the battery flow through the circuit from the negative terminal through the wire conductor, then through the bulb, and finally back to the positive terminal. The light glows when current is flowing through its filament. There are two basic ways in which we can connect these components. They are series and parallel. Come, let's see that. First, we are going to see the series circuit. A series circuit is one that has more than one resistor, that means bulb, but only one path through which the electrons can travel. From one end of the battery, the electrons move along one path with no branches through the resistors to the other end of the cell. All the components in a series circuit are connected end to end. So current through the circuit remains same throughout the circuit, but the voltage gets divided across the bulbs in the circuit. In the given picture, you can see the series circuit. Two bulbs are used as resistors. In this series circuit, charges, that means the electrons from the battery, have only one path to travel. Here, battery, key, and two bulbs are connected in series. Charges flow from the battery to each bulb one at a time in the order they are wired to the circuit. If one bulb in the circuit is unscrewed, the current flow to the another bulb would be interrupted. We put serial lights during festivals, isn't it? If the lights are in a series circuit, one burnt bulb will keep all the lights off. If the number of bulbs in a circuit with the battery increases, the lights will be dimmer because many resistors are acting on the same power from the battery. We saw that in series circuit, same current travels through every resistance and the voltage will be different across each resistance. Let us consider three bulbs connected in series. let I be the current through the circuit and V1, V2, V3 be the voltage across the each bulb. The supply voltage V is the total of the individual voltage drops across the resistance, that means the bulbs. So V is equals to V1 plus V2 plus V3. Parallel circuit. In a parallel circuit, there is more than one resistor, that means bulbs, and they are arranged on many paths. This means charges, that is electrons, can travel from one end of the cell through many branches to the other end of the cell. Here, voltage across the resistors, that means bulbs, remains the same, but the current flowing through the circuit gets divided across each resistor. See, in the given diagram, the current can flow in two paths. What are they? They are A, B, E, F, A, and A, B, C, D, E, F, A. Here, it is clear that electricity from the cell can take either path A, B, E, F, A or path A, B, C, D, E, F, A to return to the cell. From the diagram, you will notice that even one resistor, that means the bulbs, burn out. The other bulbs will work because the electricity is not flowing through only one path. All the light bulbs in our homes are connected in parallel circuit. If one bulb burns out, the other bulbs in the rooms will still work. So, the bulbs in a parallel circuit do not dim out as in series circuits. This is because the voltage across one branch is the same as the voltage across all other branches. Let us consider the three bulbs connected in parallel. Let V be the voltage across the bulbs and I1, I2, I3 be the current across each bulb. The current I from the battery is the total of the individual current flowing through the resistance. That means bulbs. So I is equals to I1 plus I2 plus I3. Difference between series and parallel circuit. Series circuit, same amount of current flows through all the components. In parallel circuits, the current flowing through each component combines to form the current flow. In series circuit, voltage is different across different components. In parallel circuit, voltage is same across different components. Components are arranged in a line in series circuit, but in parallel circuit, components are arranged parallel to each other. In series circuit, if one component breaks down, the whole circuit will burn out. But in parallel circuit, other components will function even if one component breaks down. Effects of current. When current is flowing through the conductor, it produces certain effects. These are known as effects of electric current. These effects result in conversion of electrical energy into different forms of energy, such as heat energy, mechanical energy, magnetic energy, chemical energy, and so on. So here we are going to see the chemical effect of current. See, we are going to understand the chemical effect of current by a simple activity. Okay, so we are going to make a simple electric circuit by using two pieces of wire, an LED light, and a battery. Next, in a glass of water, we are going to put the wire in the water as shown in the figure. Okay, does the LED bulbs glow? Yes, it glows. What do you understand from this? We know that electricity is conducted by metals. This activity shows that liquid also conduct electricity. When electric current is passed through a conducing material, that means a solution, Some chemical reactions takes place in the solution. These chemical reactions produce electrons which conduct electricity. This is called chemical effect of electric current. The decomposition of molecules of a solution into positive and negative ions on passing an electric current through it is called electrolysis. Electrolysis has a number of applications. It is used in extraction and purification of metals. The most general use of electrolyte is electroplating. Electroplating, the application of chemical effect of current. Electroplating is one of the most common applications of chemical effects of electric current. The process of depositing a layer of one metal over the surface of another metal by passing electric current is called electroplating. Let's do an activity to know the electroplating well. First, we are going to take a glass jar and fill it with copper sulfate solution. Next, we are going to take a copper metal plate and connect it to the positive terminal of the battery. Next, we are going to connect an iron spoon to the negative terminal of the battery. Next, we are going to dip them in the copper sulfate solution. When electric current is passed through the copper sulfate solution, we will find that a thin layer of copper metal is deposited on the iron spoon and an equivalent amount of copper is lost by the copper plate. So here, the copper is deposited on the iron spoon. So, the deposition of copper on iron spoon explains the electroplating well. So, what is electroplating? The deposition of a layer of one metal over the surface of another metal. Uses of electroplating. Electroplating is applied in many fields. We use iron in bridges and automobiles to provide strength. However, iron tends to corrode and rust, so a coating of zinc is deposited on iron to protect it from corrosion and formation of rust. Chromium has a shiny appearance. It does not corrode. It resists scratches, but chromium is expensive and it may not be economical to make the whole object out of chromium. So, the objects such as car parts, bath taps, kitchen gas burners, bicycle handlebars, wheel rims are made from a cheaper metal and only a coating of chromium is deposited over it. Heating effect of current. We are going to do an activity to know the heating effect of current. So for that we need a battery, a bulb, a switch and few connecting wires. So by using them we are going to make an electric circuit as shown in the figure. First we are going to keep the switch in the off position. Does the bulb glow? No. Now we are going to move the electric switch to the on position and let the bulb glow for a minute or so. After some time we are going to touch the bulb. Yes, we can feel the heat. When electric current passes through a conductor, there is a considerable friction between the moving electrons and the molecules of the conductor. During this process, electrical energy is transformed to heat energy. This is known as heating effect of electric current. The heat produced depends on the amount of resistance offered by the wire. Copper wire offers very little resistance and does not get heated up quickly. On the other hand, thin wires of tungsten or nichrome which are used in bulbs offer high resistance and gets heated up quickly. This is the reason why tungsten wire is used in the filaments of the bulbs and nichrome wire is used as a heating element in household heating appliances. Heating effect of electric current can be seen in many devices. Let's see some of them. Application of heating effect of current. First, fuse. Fuse is a strip of alloy wire which is made up of lead and tin with a very low melting point. This can be connected to the circuit The fuse is usually designed to take specific amount of current. When current passing through the wire exceeds the maximum limit, it gets heated up. Due to the low melting point, it melts quickly, disconnecting the circuit. This prevents damage to the appliances. Next application of heating effect of electric current is electric cookers and electric kettles. Electric cookers turn red hot when electric current is passed through the coil. The heat energy produced is absorbed by the cooking part through conduction. Next, electric kettles. The heating element is placed at the bottom of the kettle, which contains water. The heat is then absorbed by the liquid and distributed throughout the liquid by convection. Electric irons. When current flows through the heating element, the heat energy developed is conducted to the heavy metal base, raising its temperature. This energy is then used to press clothes.